Should I start? Okay.
Yeah.
Hello guys. Today we have C++ fundamentals for competitive programming. For you teach you how to create a C++ program and program with C++ in low level, and you don't need much more in competitive programming because it's more focused on the algorithmic part. So
Just one question. How many of you didn't see the C language at all? Okay. So
maybe you can mute yourself. Okay. So the first question is by C++. Okay. C++ is the most common language which is used in competitive programming. But what are the reasons? The main reason is that C++ is the fastest language that could be used by people, and it's easy to use, and it's also really fast. It's 100 times faster than Python. And there are some other properties. So we have some STLs, standard template libraries. So for example, when you want to do something, use an algorithm, you don't have to implement it every time. For example, you have the set or map already implemented and you can use them. And there are some other features that we have here. C++ has the class thing which allows you the object-oriented programming. So this is the main difference between C and C++. Also, we have dynamic memory allocation like C, and it's also portable. So it means that it would give you the same results in different environments. So let's start with the basics. In C++, C++ is a compiled language. So when you write something, it should first be compiled and somehow translated to assembly, and then it would be run. The whole program would be run. So here the main difference from Python is that you should have a template, which is these 5 lines. The first one is include, which would include some libraries like import in Python. And then you have some, for example, when you want to output or get input, you can use this library to do it for you. Then there's a using namespace std, which is not that important, but std, there are some standard functions that with this thing, you don't have to write stdcin or stdcout every time. You just write cin or cout here. So this line is not that important, but it's very useful. It would save you much time when you are developing something. Then you should have a function like int main, which is the main function that would be run when the executable after compilation of your code would be run. And at the end of this function, you should return some value. When you return 0, it means that there was no error and everything was okay. If you return 1, 2, or 3, it could mean there was a warning or there was an error. So yeah, this is the really basic template of C++. And also remember, like C language, you should have semicolon at the end of each line. Okay, if and else. These parts are really basic, so I will show them to you really fast. So this is an example of if and else. It's really simple. The most important thing are these parentheses here, so don't forget to have them. And this is if, the condition, and also the thing that would be run after if. This is the else if, which is the same as elif in Python, and at the end we have the else. And this program is checking your age and telling you something, as you can see. Loops. Like Python, we have 2 types of loops. The first one is while loop. So in front of while, you have a condition, and till that condition is true, the following code in the bracket in that scope would be run. And so this is the example. The for loop is a bit different. So in C++, we have three parts for the for loop. The first part is the initialization, which means, for example, when you're doing an iteration on I, you first define I, and in this case, I is an integer. In C++, you should define the types. We will tell you later a bit, but you should specify the type of the variable you are using. So here, you just define the variable, and you would give it the default value. Then you would have the condition, which would be checked each time that the scope is running. And after that, you have the increments that would change your iterator. So as you can see, this is a simple for from 1 to 10. And after that, we have another for from 10 to 1. The increment is I minus minus, which means we are decreasing I every time that the loop is finished. Loops in C++, we have continue and break in loops, like Python. So if you are in the scope and you say continue, that scope would be skipped and it would go directly to increment, and the scope would be run if the condition is true for the next iteration. So in this case, we are printing 1 to 10, but if I was equal to 5, we are not printing it, so the result would be 1 to 10 without 5. And then we have the same thing, this time with the break. Break means that, okay, break the loop here, and we are not continuing the loop anymore. So it will start from 10 and goes down to 4. When it sees the I is equal to 3, it would stop and it would not print any number anymore. So that would be the result. Input and output in C++. So if you remember from C, if you know the C language, we have scanf and printf from C. Here we have a simpler one, which is scene and cout. Scene would get the input from the user, and also cout would print the stuff there. So here is the really simple example here. But what's the main difference between scanf and scene? So every time that you are getting some input using a scanf, you should be careful with characters. So if you are getting a character, and after that there was an end L, which is the end of the line, you should also get that one, and then continue to get other lines of the code. But scene would handle it automatically. So if there was a character there, and if you had n character in n different lines in any style, it would handle it automatically. So it would skip the end L, the end of the line, the spaces, and things like that. So it would make your life easier. And we also have a scanf and printf. This is the same as C. So you can get some number or output some number using C, using the printf and scanf from C. And the style is like, okay, a scanf, you should give it the type hints, and also the pointers to the variables that you are storing the value in it. And here in the type hints, we have different type hints. D means integer, U means unsigned integer, and go on. So we have everything for character, string, float, pointers, and things like that. And you should be careful when using scanf with the endl. So endl means \n, the end of the line in the text that you are reading. We also have getchar and getLine like C. So getchar would get only one character, and getLine would get the whole line as a string. And we can see an example here. So here we are getting a character. Then when we got the character, we should also get another character, which is the end of the line. That's the thing that we should be careful when using C functions for input and output. And then for the new line, now we are on the new line, so the second line of the input, and we can get the whole line like this. So we will get the console in, which is cin, and also line, which is the pointer to the string that we are saving the whole line in it. So getLine would save all of the character in this line in this variable, which is line. Okay. So do you have any question till now? Good. Fast input and output. Okay. As I told you, scene is a smart function, so it would handle the space and handle characters between the inputs automatically, but it would make the input part a bit slower. So what can we do? And there's also another thing. When we have the scene and cout from C++, and we also have a scanf and printf from C, both of them are reading from the user's input. So consider that we have a console, which is the user input, and we have read until half of it. And from half of it, we change our mind. So till here, we were reading input using scene, and after that, we are reading input using a scanf. This should be handled, so these two functions, scene and scanf, should be synced with each other, so they are not reading the same line of input twice. And that would make C++ a bit slower when using both of these functions to get an input. But what's the solution? There is two commands, actually three commands. The first one is this one, and it would disable the sync between these two functions. So if you are just using scene or you are just using a scanf, you can call this function and it would disable the sync, because you are telling the program, okay, I'm careful and I'm not using both of them, so just ignore keeping them sync. And we also have cout and cin.tie, which is the flush. So cin stands for console input and cout stands for console output. Every time we are getting some input from the input console, the iterator that is getting the input is somewhere in this file of the input. So consider that we have a file as an input that the user is giving us. Scene is somewhere here and should get the rest of the input in this file. One of the things that C++ has is flushing this console. So updating that file, removing the characters that we already got as input, and things like that. It's also the same thing in console output, so it would flush the things that it already output. So there are some functionalities there, but we are not using that flush, and it's not that important in the time complexity when we are using C++. So by using cout.tie and cin.tie, we can just disable it. And we can also read and write in files with C++ just by using this command, which is free open. You just give it the file name, the type of the actions you are doing. So rpros means that we are reading and we can also write, but I mean, the main purpose is reading. This one is for writing, and you give it the console, which is std in or std out. And yeah, this is the way that you can do it. Okay, so as I told you, we have a template here. The template could be really simple as 5 lines like this, or you can make your life easier, but by saving some template in your code and use it as a every time you wanted to program something, you can use this template and start from this. And there are some type defs and defines that you can do to make your life easier. If you wanted, there is a blog on Code Forces that people share their templates. As you can see, it may be a bit longer than usual. And this is the part about variable and data types. Mattia?
So now we see in C++ how to deal with the variables, how to use them, because there are some differences from Python. From C, the functionalities are basically the same, but to use a variable in C++, we cannot do like in Python, in which we just write the name and put in the variable whatever we want, but we have to define it. And how do we define the variable? Practically, we write this line here, okay? in which we put the data type and the name of the variable. The data type means that basically for each variable we have to specify what type of data it will contain. Okay, and we can also initialize a variable together with the definition, which means we can assign it a variable, a value. For example, here we define this variable here, long number, and while we define it, we put equal 200, so we also give it a value. Or we can do it after the definition, like in this case. And now we will see all the data types. As I said, basically they are the same from C, but if you didn't see it already, we will see them now. So the first data type is integers. So an integer basically stores a whole number, and the important thing to know is that it occupies in memory 4 bytes. Basically, when you define a variable, you tell the compiler to reserve a space of memory for that specific variable. So for example, here we define the variable x, and since we say that it will be an integer, then the compiler will save 4 bytes in memory to store that variable there. Okay? Is it clear? Because this is a really important thing. Maybe you saw it already, but it is important. And as I said, with an integer variable, we have 4 bytes, and we can store numbers from in this range, basically. Even if you don't remember exactly the specific numbers, it is important to know that the range is from minus 10 to the 9 to plus 10 to the 9. So just remember the order of magnitude. And there are also long integers. So these are used to store very big numbers. So they are basically an integer. They are basically integers, but we can store bigger numbers, because in memory this time we can store 8 bytes. And so as you can see here, the range is really bigger, and the order is from minus 10 to the 18 to plus 10 to the 18. Okay, and there are also other two data types, which are unsigned integer and unsigned long integers, in which we can store whole numbers but only positive integer, basically. And so we will have one extra bit, which for integers is used in normal integers is used to indicate the sign. But in unsigned integer, we don't have to specify the sign, so we can store values which are a little bit big. But we don't cover these because they are not very much used. Then there are float and doubles. Oh fuck, sorry. Okay. There are float and doubles, which are used. Float stands for floating point numbers. Which are basically numbers with decimal points, decimal digits. And as you can see here, we can define the double pi, which stores 3.14. And the difference, again, is in the memory space we occupy with these data types. Because here there are, for a float, there are 4 bytes of memory. And for a double, there are 8 bytes of memory. So a double can provide more precision, as you can see here. And we have also long doubles. Again, they are doubles, but since we store 10 or 12 bytes, depending on the architecture, we can store numbers with greater precision. So they are the same to floats and doubles. The only thing that changes is the precision. Then we have characters. A character variable source, as you may you might guess a character, and for example, as we do here, letter equal to A, and in C and in C++, it is important to put the characters between the single quotes and not the double quotes, because the single quotes are used for characters, while the double quotes are used for strings. So pay attention to it. And a character occupies 1 byte of memory and can store 256 different values. And we see now this thing here, which is the hashy encoding of characters. So basically to each character there is a number that corresponds to it. And so we can do, let's say, a conversion between those values and characters and vice versa. So as you can see here, we can convert numbers from 0 to 255 to characters and vice versa. So for example here, if we write something like this, where we put a character and then an integer, it's completely fine, because what this does is convert the A character to its corresponding value in the hashy table, which should be like 97 here. Then adds 1, so we get 98. And when we come back to the characters, we get a B. So this line here defines the variable letter and puts into it the character B. Okay, is it clear how to do? If you already saw C, this should be clear. Otherwise, if you have questions, you can ask. Okay, there are also in C++, not in C, this is just for C++, Boolean variables, which can store 2 values, either true or false, or we can say 1 or 0. And a Boolean utilizes 1 byte in memory, so 8 bits, not just 1 bit. And in C++, but also in C, there is this similarity. A false value is represented by a 0, and every other non-zero value will correspond to true, okay? And so, for example, here we define this Boolean B, which takes the result of this inequality, 5 greater than 3, which is true. So B will store the value true, okay? And then there are, in C++, there are also strings, which, let's say, they are not properly a data type. It's more like a data structure, a really simple data structure in C++. And so in this data structure, we can just put a string. And as I said before, strings can be put into, have to be put into between double quotes and not single quotes. And one difference from Python is that we can modify each single character in a string. So for example, you can see here, we define the string John, and then we change the first character into an S. And we can do this, and this is a difference from Python, in which for some reason we can't. Yeah, that's it. And there are also some functions and operations which we can perform on strings. So the pushback function will append 1 character to the end of the string, or we can concatenate 2 strings with the plus operator. We will see how in the example. Or we can retrieve the length of a string just by using the length function. And so we don't have to do a loop to count how many letters are in the string. So this is, let's say, one main difference from, actually, in C there is also the string length function, but this works in another way. And it works in constant time. So let's see the examples. Here I define 2 strings. And to the first string, I push A, so this string here becomes first A, and then I do the concatenation between string 1 and string 2. So the first string 1 will become first, A, and second, all put together. And we can get the total length by using this one. Okay, is it clear? Any doubts? Okay, here we come to integer operation. Do you want to?
So,
You want to use this?
so in C++ we have integer operations like other languages. Here we have the division. The most important thing about division is, okay, in Python the division is with two different characters. One of them is a slash, and one of them is this thing, if I'm not wrong, with one slash.
Yeah.
And one of them would be integer division and the other one wouldn't be. In C++, so both of them are using single slash, and the type of the output depends on the type of the variables that you are using. So if you have two integers that you are doing the division between of them, the result would be integer division. So if it was 4 divided by 3, it would be 1 with no decimal. But if both of them were float or double in C++, the result would be something 1.3333, something like that. We also have power function. So in Python we also have power, and it would handle really large numbers. But in C++, again, it's not like that. So if you are using the power function, you should be careful with the overflow. If the result is integer, it couldn't be larger than 10 to power 9, and if it's long integer, it couldn't be larger than 10 to power 18. And this is the function that you can use for the power. And there is the time complexity of this function is not constant exactly, because in C++ they have implemented the power with logarithmic time complexity, so it's not that fast. There is also modulus, which is this thing, which would give you the reminder of the integer division. So the remainder of 7 divided by 2 is 1, because 7 is odd. And this is the operator for it. So there are some examples here. So the first one is we have 2 and 3, and 2 to power 3 is equal to 8. And because both of them were float, the result would be also float, and it would be 8.0. I mean, it's a float variable, and z is also float. But if both of them were integer, the result of power would be also integer. Here we also have 7 remainder by 3, modulo 3, which would be 1. And also, these are other things that I've told you. So the important thing was here. The normal division, if you want the decimals, I don't know how to call it, you should convert both of the variables to float and then do the division, unless you would get an integer. And we also have some bitwise operations. So if you write the number in binary representation, there could be some bitwise operation that you can do. The first one is AND, which would take each. So consider both of the numbers in binary representation. For each bit, it would the result would be the AND of this bit. So each bit is ANDed, and OR is the same, but with the different bitwise operator. We also have XOR, if you know what it is, but if you don't know, it would understand if it's giving you if the bits are different or not. And we also have left shift and right shift. So if you write the number in binary representation, if you shift it to the left, somehow you are multiplying that number by 2 to power of number of shifts, So if you are, let me draw an example. So if you have this number and you shift it to left and add 2 zeros here, so you're doing something like this, the result is exactly the same but multiplied by 2 to power 2 because we shifted by 2 to the left. And if we do it to the right, it's exactly the division. So if we shift it to the right, these two bits would be cancelled, and it would be result would be this one, which is x multiplied by 2 to power 2. This one is integer division. And yeah, these are some examples. If you wanted, you can check it later. The most important part was this one. So left shift means multiplying by 2 to power something. Right shift means dividing by that. STL, you want to go on?
So as we mentioned previously, C++ provides the standard template library, which includes data structures and functions, and we'll go through those because they are really important. Okay, this is the thing I just said. Okay, first thing, we have the pairs, and which is it is a container which contains 2 different values, and we define it as in this line here. Okay, so what happened? Okay, we put the keyword pair, then we have to specify the first data type and the second data type, and then we write the name of the pair. Why we have to specify the 2 data types? Because they can be different. So we can create a pair which can contain 2 different, let's say, 2 variables of different types. Okay? And it is the thing I just said. And we can access the first and the second element of a pair with this syntax. So to access the first value, I have to put the dot and first, and for the second one I put dot second, and this is how we can access the values. So here there is an example. There are examples on how to define and initialize pairs. For example, in this line we create a pair which contains a string as the first value and an integer as the second value, and between the parentheses we can put the values to initialize our pair. So for example, in the first value will be Alice, and the second value will be 30. Another way to assign values to the pair is with brackets, curly brackets. So this syntax here assigns to the pair Bob as the first value and 25 as the second one. Or as I said, we can access each element individually with dot first and dot second. And of course we can, by doing my pair dot first, we can take that value and put it in another variable. For example, as we did in this line, we take my pair dot first and we put it in the variable a. And another function to, let's say, split the values in a pair into 2 separate values is with this function, tie. So it splits, the first value of my pair goes into variable a, and the second one into variable b. Then there are vectors, which are C++ vectors are dynamic arrays which are resized automatically, and we can define them with, as in this line here. We put the keyword vector, then the data type, and then the name. Because differently from lists in Python, in vectors, all the elements must have the same data type. and we have to specify what the data type is. And with this syntax, we create an empty vector. With this one instead, we can open the two parentheses, and put some arguments. The first argument, n, specifies how many elements the vector will have at the beginning. So it's to say to the compiler to create this vector, which will have these n elements at the beginning. So it will reserve in the memory n slots for all the elements in the vector. And we can initialize all those elements by putting a second argument, which is value. And these arguments are not mandatory. As we can see here, we can create an empty vector with no initialization whatsoever, and it will be fine. Or when we define a vector, we can also put all the elements. We can already put some elements inside it, as in this case, we open the curly brackets and we put those elements into the vector. And remark, all the elements, as I said, must have the same data type. We cannot put a string and then an integer, or an integer and then a character. Okay, these are some examples of what I just said. Okay, vectors are zero indexed, which means that the first element in a vector will have position 0, index 0. And we can access, we have random access, which means we can access each element in the vector by specifying the index, just like with arrays in C, or also with the lists in Python. And one remark, if we don't specify the size of the vector during the definition, we create an empty vector. So it will be empty, and if we try to access one element inside it, we will get an error, because there are no elements inside it at the beginning. And we will see in a bit how to, let's say, add more elements to an already defined vector. And another important thing to notice is that vectors and C arrays are very different, because in C, arrays have a fixed size, and we cannot do anything with that unless we do some reallocations and strange things, but I will not mention them. And also a lot of the functions that we will see in a bit cannot be used on C arrays. And one note, in C++ it is also possible to define C arrays, but as I said, they are different from vectors, so be careful on that. And we can create more complex data structures. So for example, we can define a vector of vectors, and also an array of vectors, but not a vector of arrays. So it is a little bit strange, but it is like that. Okay, for example, here we can define a vector of vector containing this 20 means that the vector of vectors will have 20 vectors at the beginning, and equivalently with this line we can create an array with 20 vectors. Okay, there are two ways to iterate through a vector. The first one is like we do in C. So we do this for loop where we put the index, and at each iteration we increment the index and we access each element of the vector. But we can, in C++, there is this feature in which we can also iterate through a vector by element. And how do we do it? We do it with this syntax here. So it is again a for loop. Then we put the keyword auto. What this keyword does is that it automatically gets the data type of the elements which are in the vector. For example, this x, since we are iterating through this vector here, u, and which is a vector of integer, this auto keyword will, let's say, become int, because this x is a temporary variable which is used to do the iteration, and we can translate this statement here with for integer x in u do something. So for each integer x in the vector u, and we do something. And now here we see some functions which can be used on vectors. The first one is the pushback, which works basically exactly like for strings. So we can append elements to the end of the vector, and these will of course automatically increase their size. And we can do this after we have already defined a vector. So for example, if we create a vector which is initially empty, but then we use this function here a lot of times, we will expand the size of that vector. And one remark, when we use pushback for strings, of course, what we can append are characters. Of course, we cannot append integers to strings. Then there is the popback function, which removes the last element in the vector. And then there is this function here, which is maxElement, which will get it returns an iterator to the maximum element in the vector. An iterator in C++ is basically a pointer. So to get the actual maximum element, the maximum value, we have to dereference it with the star, exactly like we do in C. So here is the example with all these features. Is everything clear until now? Do you have questions? Okay. So two words on iterators. As I said, they are pointers, so they point to elements in the vector. And some examples are these begin and end iterators. So the first one points to the first element in the vector, but the second one does not point to the last element in the vector. It points after the last element in the vector, which means that if we try to dereference it, we will get an error, because we will try to access a place in memory in which we should not have access, because it is outside the vector. So it is really important. And so instead of using these iterators, we can do v.front and v.back to access the first and the last element. Another thing we can do is assigning a vector to another vector using this operator here, the equal operator. And this operation is linear in the number of elements we want to assign, because of course we have to copy each single element and put it and append it on the other vector. So let's do some examples. So here we define the vector u with these elements, and we can create another vector v and set it equal to u just by doing this, without doing any other loops or strange things. And then there are the front and the back functions. Some more operations. There is the v.clear, which takes a vector and removes every single element. And after this operation, the vector becomes empty. So again, we cannot try, there are no elements inside it, and if we try to access something, we will get an error again. Then there is the resize function, which takes two arguments, x and y. So x is the new size of the vector, and in the case we increase the size, So we create, we put more elements inside the vector. The y argument specifies the value of those new elements which will be inside the vector. This v.empty checks whether the vector v is empty or not. It returns 1 if it is, and 0 if it is not. And the v.size function instead returns the number of elements in the vector. And it works in constant time, so it's not linear in time, but just constant. And okay, we should pay attention to something which is related to the size function, which behaves strangely in some situations. But I will skip this because there are more important things, and I know you are tired, so let's see some important things. And these functions here are also valid for the other data structures that we will see in a while. Okay, sorting. So if you did some programs in C, you know that sorting is a nightmare. But fortunately in C++, okay, we have a built-in function, which is the sort function. We can use it on vectors using this syntax here. So sort, name of the vector dot begin, name of the vector dot end. And with this, we sort the vector in increasing order, and with r begin and r end, we sorted in decreasing order. The r stands for reverse. Okay, so we sort it in reverse. And we can also use the sort functions, the sort function for arrays. And we just put the name and then a plus the size of the array. And the sort function works in linearithmic time, so n times log of n. Yeah, basically that's it. Okay, do you want to say something about comparators?
Also for sorting, so sometimes you want to sort the numbers.
Okay, come here, maybe.
So sometimes, so here we have the vector and we want to sort it, but we want to sort it that after sorting it would be decreasing. So we can do the thing that Matthias said, so we can pass the end of the vector and the beginning of the vector in the opposite way to sort it correctly, but we can also pass a function to the sort command, which is this function, which would compare the integers for us and give us the right order. This is also important when you have pairs, so the elements in the vector are not exactly numbers and it's not that easy, so maybe sometimes you have pairs and you want to sort those pairs based on something custom that you wanted and it's not implemented. And here you just define the function and you just compare two elements and it would sort it for you. Basically it would use this function as the compare function. And in C++, like Python, we also have lambda function, which is this thing. So we can write this thing instead of having a function, which is the lambda function. If you wanted to know more, you can search about it and you can learn it from here. And yeah,
We'll continue.
yeah, this is the thing that I've said. Set.
So, so now they talked about the vectors, but so when you have a list of numbers and you want them sorted, use the sort in vector. But what if we have to add and delete and add again other numbers in a data structure and have already those numbers already sorted without doing the sorting again in the vector? We can use the sets. So what are the sets? They are containers that store unique elements in increasing order, so already sorted, and we can define them as set the data type, in this case integer, and name it as s. And then to this set we can insert and erase elements, and we can also access the smallest and the biggest number. For example, for inserting, we use s-point insert and then the number we want to insert. And when we insert a number in the set, it already puts it in the correct order in log n complexity. And if we want to erase delete the number, we use s-point erase x. And also, if we want to get the smallest or the largest number, we just access to the first the pointer that is pointing to the first element in the set, that is s-point begin. And if we want the biggest, we can point to s-point r begin. We have to remember that they are pointers, not directly the number where they are pointing. So we have to use the pointer notation to have the correct number. Let's see an example. For example, here we defined a set, then an integer number 5. We inserted 10, 8, and then 12. And we know that after this we should have a set with the order 5, 10, and 12. Then we try to insert again a, but since it is already in the set, it will do nothing to the set. And then if you want to have the biggest and the highest number in the set, we just do cout s-point begin and s-point end with the pointer notation. And we will have 5 and 12. So as I said, every operation in the set is in of log n, so it's logarithmic, and because they are implemented as binary search trees. But they don't have indexes, so we cannot access directly the set using indexes. Instead, we can just we can iterate through all the set and see outputting what is in the set. In this example, it will output 1, 5, 6, and 10 with this short notation. There are other functions that are interesting in the set. For example, we can find if an element is in the set using the find operation. But we have to remember that if x is not present in the set, it will you will have as output the pointer to the end of the set that it is outside of the which points outside of the set, so we have to check this. Instead, if you want to see which is the smallest number in the set that is larger than a given number, we can use the upper bound function. Instead, if we have to see which is the first number that is equal or greater than x, we can use the lower bound function. And those functions can be used also in in vectors. But okay, if there is no value that is greater than x, we will have again s-point end, the end of the set, as a pointer. So let's see here. Okay. This is an example. For example, here we are finding, we are searching for 7 in the set, but it is not. So the pointer will point to the end of the set, and we will say that we didn't find it. Instead, if we search for the upper bound of 8, it will point to 10, since 10 is the first, the smallest number greater than 8. And at the end, if we do lower bound of 5, we will get 5, since 5 is equal or greater than 5. Okay. Yeah, we are always to make sure that we are not getting the end of the set. So, and the complexity is of log n.
The other thing is binary search on vectors. So you can do the same for vectors, but you should be careful that the vector should be already sorted. And by using this command, you can do the binary search without doing the binary search, implementing the binary search from scratch.
Okay. Okay, so but so these as we said, these sets are they get the only unique elements. Instead, if we want to have multiple repetition of elements in a set and having all the numbers in the correct order, we can use multisets. That, for example, you can add the same number more times. So how can we do operation in the multiset? For example, if we want to delete a number from the multisets, for example, if we have 1, 2, 2, and 3, and we want to delete 2, if you use s-point erase 2, we will erase every occurrence of 2 in the multiset. So after the s-point erase 2, we will have 1 and 3 in the multiset. Instead, if you want to erase just one occurrence of 2, we will use s-point erase s-point find x, and because s-point find x will give you the iterator to the first occurrence of 2, and then we will just delete the number that is that is pointed from the iterator. So we will delete just one occurrence of 2. We have always make sure that it doesn't return s-point end. We have an example here. For example, we created a multiset that it will have 1, 1, 3, 5, and 7. And then we insert another 3, so we will have 1, 1, 3, 3, 5, 7. Then we will erase 1, s-point erase 1. This means that we will erase all occurrences of 1, as I said, and we will have 3, 5, 7, 3, 3, 5, and 7, and then using s-point erase s-point find 3, we will erase just the first occurrences of 3. So at the end, the final multiset will be s equal to 3, 5, and 7. And okay, we finished to talk about multisets and sets, and then now I can talk about a map that is like the dictionary in Python, where we store some k-value pairs, and we can define a map using map, data type of the key, data type of the value, and then name the variable as we want. Yes, and as sets, maps are implemented using binary search trees. And we have to know that in maps, the keys are ordered in ascending order and uniques, and the values of the keys are unique. So we can do one of these two. To insert an element to the map, we can use my map points insert and then the key value pair, or instead we can just use the my map and then the index, the key of the map in the square brackets, and then equal to the value. We can also modify the value in the that is related to a key by doing this. Instead, if you want to delete a key from the map, you can use my map point erase key, and if we want to say if the key is present, we can use my map point find of k. So let's see this example. We define a map of k, integer k, and integer value. We inserted at the key 1 the value 4. Then we inserted the key 10 with the value 7, and then we modified the value of the k1 with the value 3. And then we erased the key that is 10. So at the end, we will have just a map with the key 1 and its value 3. And also, as in sets, we can iterate through a map by element. This time we will have as using this notation we will have in this case x, that it is a pair where the first element of the pair is the key and the second element of the pair is the value. So here in the comment center, I didn't want to do this. We will have 0, 1, and AC as values because we created this map. As in sets, they are implemented using binary search trees, and every operation in the map is works in a logarithmic time complexity. And also, there are other type of maps that are hash maps, and they can be defined by using the unordered word, like another map in my map. It will be not an ordered map, but so thanks to this we can have faster, we can have benefits in time cost, and they can be useful in some problems, but in very complex problems. For now, we just stick with the map notation that is pretty fast too. Okay, I will go. Okay. Now I can continue as you want. There are other data structures in C++.
Sorry, we are almost at the end.
Yeah, I think we are at the end of the slides. There are the stack, that it is last in, first out data structure. You can think about a stack like a pile of dishes where you put one dish over the other. Then when you want to take a clean dish, you take the first, so the last one you put, and so you will put the one that is at the top of the pile, and it can be useful in some problems. So you can define it as stack data type my stack. So as I said, you will have only access to the top of the stack, and when you want to push another dish, you can just write my stack point push x, and if you want to see which value is at the top, you just write my stack point top, and if you want to delete the top of the stack, you just write my stack point pop. That removes the element of the top of the stack. So if you want to access to the element that it is at the 5th position of the stack, you have to pop every element over the 5th position. So you have to do the pop 4 times. This is an example. Okay. Yeah, we are pushing every integer from 0 to 4 in the stack, 4 included. And then if you want to output every element of the stack, you will read 4, 3, 2, 1, 0, since you pushed 0, 1, 2, 3, 4, and then if you want to access it, you have first 4, 3, 2, 1, like I said. And then there are the queues that are similar to stacks, but they work in a different way, since they are first in, first out data structures. This means that they are the opposite of the stack. Since the first element that you add to the queue, it will be the first you will delete of the in the queue. So you will have access only in a queue. You can have access only to the first or the last element of the queue. Okay. To insert some elements in the queue, you can just write queue point push x, and you will add another element in the queue. And if you want to access the first or the last element of the queue, you just have to write queue point front, that takes the element at the front, and the queue point back, that takes the element at the back of the queue. And if you want to remove an element, you can just remove the one at the front of the queue, and it will return the value of the element using queue point pop. As similar to the stacks, if you want to access another element in the queue, you have to first pop all the other elements which are before it, so which entered the queue before the one we want to access. For stacks and queues, all these operations, push, pop, are in constant time, so pretty fast. Okay, this is a similar example from before. We push in the queue every number from 0 to 4 included. And we say A that is at the front of the queue. While the queue is not empty, so while there is some elements in the queue, we see out the front of the queue. So in the reverse order of the stack, we will see 0, 1, 2, 3, and 4, and then we pop them. Okay. If you want, as you want.
So last thing we will see today are priority queues, which are a special type of queues in which the element at the front is always the maximum one, and we can define the priority queues as in the following line. So it's the standard priority queues data type and then the name, and they are implemented as heaps. If you don't know what a heap is, don't worry. Just skip this part. But the important thing is that they work in logarithmic cost, so big O of log of n. And a priority queue is not like a set. So you can access always the maximum element, but the queue in itself is not ordered. And also we don't have random access in queues, which means we cannot access whatever we want. We can just access the first element. And so to access the maximum element, which is at the front, there is a difference from normal queues, and we have to use the .top function instead of the .front. And also for priority queues, we cannot access the last element, so there is no .back function. And here there is the example. So we put in this priority queue all these elements, and at the front there will be the 7, which is the biggest one. Okay, I think we can stop here. This is let's say an application which can be used more in competitive programming, but it's not that relevant. I know we said a lot of things, and I don't expect you to have understood everything, but the slides will be available, and they should
available in the group.
Okay. They should be pretty detailed, and maybe we should upload also the recording, and also if you have doubts or questions, you can ask.
And in the last slides
There are also resources and
the resources and the links to our website, LinkedIn, Linktree, including Instagram and all the.
If you are interested or want to find out what we do, this Saturday, as every Saturday, we organize some meetings in which we discuss competitive programming problems. And so if you want to see what we do, just come on Saturday. We publish the announcement with the room and the time in which we organize these meetings, and if you want to come, you are welcome, of course.
If you have any question, you can write them in the group,
Yeah.
group, so we have the answer here.
Thank you for attending.
Thank you.